Okay, this is our explanation video or demonstration video for addecho.c. First, I'm going to compile the code gcc -wall -w I'm going to output it to a file called addecho, and I'm building from addecho.c. Compile, and it fully compiles and creates the executable here. And to show the regular running cases, we've created a shell program which runs the basic tests. So if there's an argument, if there's one argument, two arguments, three arguments, if there's the correct wave file as the argument, if you have D, and then all that stuff, if you have D and V, if you've got 7 arguments, this is where we run the default values of 8,000, 4,000, because we don't provide D or V. And then all the rest of the codes are the provided test cases from the website, which I'll be comparing against the provided files from the website that I've already downloaded here using cmp-l, which should return nothing if the files are all the same. So to do that, I'm going to run program running, my shell program. It's going to create all the different files where if the arguments do not match up, it provides the following exit message printed to standard error or std error. If I give it a wave file, it provides the destination file, even if it doesn't have a .wave at the end. And it follows the same format all the way down. The default values work, providing no errors. And CMP provides no extras, meaning all the files are the same. Just to prove, let me run the generated file. And the last thing is in our .echo or addecho, we have used getopt for the different options like -d and -v. And we've used the case statements, which was a requirement.
So the first half of our program is a lot of sanity checks. And so after we enter in after we run our program with a few arguments, we have to check, do the number of arguments make sense? If there are less than 3 arguments, then clearly we haven't given it enough arguments. If there are 4 arguments, we've given either an option with no parameter or something else has gone wrong. 6 arguments, same thing. And if we have more than 7 arguments, that's too many arguments. Now, our default values for the program will have a delay of 8,000 samples, and we'll have our volume by default scaled by 4. This means that after 8,000 samples have been read, we'll start adding in the echo to the file, the original sound file, and the volume scale being 4 means we're reducing the volume of the original by a factor of 4 in the echo.
For our project, we had to use getopt as per the documentation or as per the write-up. And so for that, I've created a int opt and making sure that we're keeping track of the amount of options. By using getopt, we're taking account into the cases of D and V. For case D, that's for the delay. Case V is for the volume scale. Other than that, all we're doing is taking that argument after the D or the V and making sure that it is an integer using strCompare. And if it's not an integer, we're printing out an error message to std error. And if it all goes through perfectly, we're increasing the amount of options as well as, and doing the exact same thing in the volume scale.
we have a second if statement here, just to make sure that our arguments are indeed making sense again. So if we have 3 arguments and we have more than one option, if we have more than one option, then clearly we're missing a source or a destination file. Similarly, for if we have 5 arguments and we don't have one option, then something else has gone wrong. We have an argument that doesn't make sense. Similarly, with having 7 arguments and not having 2 options. Then we'll initialize our files, our file pointers, since clearly our arguments make sense now.
This code now opens the source wave file by using the read binary mode. The location of source wave is found by using opt-in, which is related to the get opt, as it appoints the first argument that is not an option, which will always be the source wave file in this case. Then we open dest wave by using write binary mode so we can create or alter the wave file. After that, we create a short array called header and read the source file's header into this array. We then find the 2 integers related to size in the header and increase their length by delay times 2 so that the header is accurate to the file size after the echo is added to it. We then use if write to copy the header from the source wave to the destination wave.
After writing the header, we create a short array of echo, where we don't actually know the size of it until the arguments are read. So we have to malloc using the delay and its size of a short. From there, we can do our actual computing, but because we've malloced at the very end of our code, we always have to free.
Our actual computation here, we initialize a counter variable to keep track of how far along through the delay that we're in, as well as a short to keep track of two shorts to keep track of the bytes from the original and combined, and bytes for the combined audio. If for each short that we read from the original file, we check if delay samples have been read yet. If they have not been read, then we will continue to copy over the original file. But if we have passed if our current delay is larger than delay, then we can start writing in the echo, combining the echo with the original sound file and writing that into our new file. At the end, once we reach the end of the original file, then we still have a delay number of we still have to write delay number of samples from our echoes, which is what this for loop does. After that, we close both files and that's the end of the program.
Okay, for our edge cases and demonstration testing, we have once again created an edge case shell program, which checks for most of the common edge cases, such as 0 for the delay or volume scale, if it's a negative number for delay, if D or V is used twice, which can be seen here and here, or if it's a non-integer for D or V, such as high, which I will run with clear and dot edge cases like this. And you can see that our edge cases don't print out any errors. They return some useful information to the user, such as the delay must be a positive integer, same thing. And our computer code does not crash if you use D or V twice. It actually just uses the second value as the value, or as the argument. And the last thing is, if it's not an integer, it does the exact same thing and asks for a positive integer. We have also created our own test cases, which can be shown by taking this small test case.wave and creating an echo where the delay is 5 and there's a volume scale of 2. From here and the creation of the echo file, we can look at what it should be.
So the original wave file that we had was for each sample. Each sample would be would have a value that would be 2 times their index, starting from 0. Hence 0, 2, 4, 6, 8. There are 20 samples in total, so our last sample would have a value of 38. When we call add echo on it, we can see that with a delay of 5 and a scalar of 2, we can see that because the delay is 5, the first 5 samples are unaffected. At the 6th sample, since 0 scaled by anything is still 0, the value is unaffected. But after that, we have instead of a value of 12, we have 13, 16, 19, all the way up to 52, which would be the end of the original file. After that, we just have our echo. We just have our echo sound effects with 15, 16, 17, 18, and 19. And because we have a delay of 5, we have 5 samples that will add on to the to the length of the original file. You can see underneath the sample the values of each sample is this is the value of each of echo. You see that 0 times 0 divided by 2 is 0, 2 divided by 2 is 1, 4 divided by 2 is 2, and so on and so forth.
To check this file, I'm going to shove it into this program, echo, small test, and we can see 2, 4, 6, 8. This would be 10, 13, 16, and 19. And as you can see, if this is 19, this is the last number in the file, which is also 19, meaning our program's echo is correct. For another test, we also have this tiny.wave, which I can do the same thing. I can use our program and load it up, creating an echo with a delay of 10 and a volume scale of 2, and creating an echo right here, which can be seen here.
Yes, so in this test case, I call it tiny wave because there's only 5 samples in it. And since the delay is 10, actually the results should be that the first 5 samples will be copied to the destination wave exactly the same, and then there will be 5 more samples that are 0 samples, so that as it's not time for the delay to have finished yet. And then once the delay finishes, then the echo will occur, which leads to the last 5 samples of 0, 1, 2, 0, 1.
Same thing. Let me quickly load up that file, tiny echo. And as you can see, we've got the zeros, we've got the 2, 4, 1, 3, all the following zeros, and then 1, 2, 0, 1, in the same order as this. In our last case, we've got a 0 wave, creating that test case, which is shown here.
So this test case is just to show that if all the samples are 0, that no matter what, the values of the samples won't get affected, as no matter what you scale 0 by, it will stay as 0. So since there's a delay as 1, it will take 1 0 from the original file, and there will just be 10 zeros as the echo, as the original file is 10 samples of 0.
Last time, I'm going to load up a file. And here we can see all the trailing zeros that do not get changed.
One of the issues that we encountered while making our code was with our while loop, which calculates the echo. What ended up happening is that we had an issue where the loop would run for one more instance than what was required. We found out that this was because of the loop condition that we were using, which was checking for the end of the file, and as long as it hadn't reached the end of the file, it was to continue. However, due to the way that the function for FEOF works, it would continue to go through the loop even on the last line where it had reached the end of the file already. Thus, we had to change it to fread, where we check if fread equals 1, because then that allows us to know that fread actually read a value this time, which allowed the code to work and read and go through the loop in the right amount of time so that the echo could be calculated properly.
The second largest problem we had was with the X0 samples, where if the delay was longer than the actual size of the file, of course you need to input zeros so the echo doesn't cut off, and there's no issues with that. That issue built on the fread issue versus the end of file issue, because we were doing one extra loop through our code, we were essentially adding one extra zero and one extra number to our code, which meant when we were CMPing all of our files, every single byte after the header, after our while loop began, was off by 1, which made wildly different problems, which meant as soon as we added in a 0, things that should have been 0 had values, and things that should have had values were being set to 0.
A third issue we faced was with building test cases. It was kind of hard to find, to use other files to create the desired circumstances for our test cases. We couldn't just use the provided files because they fall within typical usage, and some of them would be sort of difficult to work to and some of the provided files were sort of difficult to work show to compute the proper values that we needed. However, what we ended up doing was we ended up finding a wave file generator, which allowed us to create custom wave files so that we could do testing on, which made it a lot easier.
As for our contributions to the actual project, I mainly worked on the get opt section with the different switch cases and different error testing built into that, such as comparing the strings, making sure the options and their inputs were integers, and using compare and strtool. I also worked on the actual while loop. I began by using the not or while not end of file, which was changed eventually by one of my other group members. But while I had somewhat working code, I was working on writing the sounds to the files and then echoing them later on if need be. And then I also worked on finishing off the last echoes when the source file was completely read.
For my contributions, I started with doing the source wave and destination wave areas where we open those files and also the error handling for them. I also did the reading in the header from the original file and changing the header size, also copying that header to the destination wave. Also, as just mentioned, I helped with the while loop in terms of changing the condition to the fread, and also at the end with the free echo and closing the files.
I mostly I worked on actually bug testing the code, to making sure that it worked, and creating test cases for it and checking that everything was indeed as it should have been. As well, I also wrote the man page